Science. Cow juice, vinegar, plastic, the history. Okay, I'm not using that. The history. The history and idea of turning milk into plastic is not an old one. In fact, the first recorded instance of turning milk into plastic was recorded back in the time of the ancient Egyptians. They were known for using it to very simply make simple objects, like molding tools that they could use in their shops. In the early 20th century, a German chemist named Adolf Spindler began experimenting with ways to make cast-in plastic. He found out that a very simple and cost-effective way was to use milk, distill it with vinegar, and leave it to sit for 24, 48 hours, depending on how hard you wanted it. At that point, you could mold it into whatever you wanted it. It was going to be a solid, milky white plastic substance. But the issue is there wasn't a defined recipe for how to make this substance. And that is what we're going to be talking about today. My experiment consists of 3 different trials, trying 4 different vinegar to milk ratios to figure out which one is the most effective way at turning milk into plastic without making it too hard and chunky to where it's unusable, and making sure that we're also using the formula to its full extent. Let's get down to the hypothesis. If we mix 1 tablespoon of vinegar to 1 cup of milk, 2 tablespoons of vinegar to 1 cup of milk, 4 tablespoons of vinegar to 1 cup of milk, and 8 tablespoons of vinegar to 1 cup of milk in 3 separate trials, then the 2 tablespoons of vinegar to 1 cup of milk will make the most effective plastic material, because the 8 tablespoons will be too much of the compound, making it unusable, and the 1 tablespoon of vinegar won't be enough, not using the formula to its fullest extent, because the 2 tablespoons is a good in-between middle ground, and with the chemical makeup, that should be the perfect spot to get the milk to curdle. That way it can dry and then turn into cast-in plastic. Oh crap, I gotta let my dog out. Now let's get into some of the results. So something interesting that I found when I was doing the actual trials, and you'll see a picture of it on the screen right now, is the 8 tablespoons of vinegar to 1 cup of milk couldn't even be strained through the strainer into the cup to separate the plastic from the leftover residue. It was just too chunky almost, and it was in too many different parts. It wasn't effective whatsoever. And for my next 2 other trials, it was the same way. I don't have pictures of those 2 other trials, but it looked very similar. And for that reason, we can automatically rule out that 8 tablespoons of vinegar to 1 cup of milk is not a good ratio. That does not work. Something I did notice though, and it was kind of after I had started my experiment, but I ended up making it another variable, is the color of shirt that I used to strain the substance through to just get the plasticky part. I used a blue tie-dye shirt, and I was doing the experiment and I assumed, well, it's vinegar and it's milk, so the blue residue is probably going to leak out into the leftover liquid, but it didn't. And so I found out that for whatever reason, I didn't look deep into the molecule because it was way above my grade level, but however the milk compound makeup is it doesn't strain colors out of clothing, which I found really interesting. So my substance that I was left over with was completely milky white, which honestly kind of shocked me. Another thing I noticed was the compound that was 1 tablespoon of vinegar to 1 cup of milk it was not working to its full extent. Maybe half of the milk would turn into a substance that could be used for plastic, but the other half would kind of just be left there sitting in this weird, like, go-between of milk and vinegar and plastic that looked kind of disgusting. But I did find, like my hypothesis showed, that the 2 tablespoons of vinegar to 1 cup of milk was the perfect combination. And looking at the results, we can see that every time it made a reliable source of plastic, and we were able to repeat it 3 different times, proving that it was correct. So let's get into my results. All right, so I have my display board sitting here in the grass right now, so I'm going to read my results off of that. So for the first trial, when we put 1 tablespoon of vinegar to 1 cup of milk, the substance that we could actually use to make plastic came out to weigh 6.5 grams. This was after I'd let it sit and dry and really soak all the moisture out of it, so there was no extra variables. Now, this 2 tablespoon to 1 cup of milk, it drastically doubled the amount of plastic mixture to 13.1 grams of usable plastic. And that is crazy. I mean, it was a chunk of this plastic made out of 1 cup of milk, which is really efficient for making that on a large scale. Now, the 4 tablespoon mixture in the first trial made 10.2 grams, which is fine, but it was also a little milky and a lot harder to strain and a little bit thicker. And then, like I said previously, the 8 tablespoons to 4 cup of milk didn't work at all. It was just too curdy. It was not good. Going to the second trial, we're just going to go through this quickly. 1 tablespoon to 1 cup, that did 5 grams. 2 tablespoons to 1 cup, that did 12.9 grams. 4 tablespoons to 1 cup, that did 8 grams, which is far down from what it was. And that is why I'm saying that the 4 tablespoons is not reliable. 8 tablespoons, again, didn't work. Moving on to the third and final trial, the 1 tablespoon produced 6.6 grams. The 2 tablespoon produced 13.4 grams of usable plastic. The 4 tablespoon produced 10.2 grams, and the 8 tablespoons, again, did not produce well. So this proved my hypothesis correct, that if we put milk and vinegar together to create a plasticky substance, then the 2 tablespoons of vinegar to the 1 cup of milk will work best, because it is the perfect ratio of milk to vinegar to maximize the formula without making the milk too chunky or curdy and unusable. So that's my science project, and now we'll move on, and I'll just show you guys some pictures of my board, so that way I don't have to bring it in. So thank you very much, and I hope the rest of you do great on your presentations.